Okay, here is one doubt of student, senior target batch. I thought uh, we can have a video on this. So here you can pause the video and see the question for yourself if you want, and try the question. I'll jump over to the solution here. Uh, so in this, it is asked like work done by external agent in taking a unit positive charge slowly from A to C, and it's given that the magnetic field is increasing with time and magnetic field is into the plane, as you can see from this cross symbol, isn't it? So magnetic field is into the plane and increasing. So we know that the electric field lines, which are like non-conservative electric field lines, which are circular in nature in the cylindrical region, so this circular electric field lines are going to be anti-clockwise because the magnetic field is increasing. So one such magnetic field line will be like this here, and these field lines will be anti-clockwise like this. Okay, why the field lines are anti-clockwise, that we can understand from Lenz's law. Okay, so like that there are many such field lines. Each field line is circular in nature. So one field line may be like this, then another field line like this, then another field line like this, and each field line are anti-clockwise. Okay, then if a positive charge is taken from A to C in this radial straight line like this, then the work done by this external agent against that electric field is zero, because no matter where the charge is, during this tiny small displacement along the path, the displacement and the electric force are perpendicular to each other, because this electric field will be tangential to the electric field line. For example, let's say that the charge has reached this point. Let's call this point as point M. So this charge is going to undergo a tiny small displacement in this direction, in radially inward direction towards the center. But what about the electric field? The electric field line is tangential. So this is the electric field and this is the tiny displacement. And since the electric field is tangential, the force from the electric field is tangential, and so it will do zero work. And so the external agent also needs to do zero work in this path from A to O to C, straight line path. So this work done from A to O to C is 0. Then comes the path from A to P to C. So let's rub this. So in this path from A to P to C, how much is the work done by the electric field? So the electric field is doing actually positive work, because if the charge is moved tangentially from A to P to C, and the electric field is also tangential in the same direction, and so if you take a small part of the path, and let's say the small part of the path is this pink part, let's call it a ds part. So a small displacement is tangential along this ds, and electric field and thus electric force is also in the same direction of this pink arrow ds. So electric field force and the displacement of the charge are in same direction, so work done by electric field is positive. And like that, work done by electric field is positive at each and every point of this pink path APC. And if the electric field is doing positive work, then we can say that work done by electric field plus work done by external agent is equal to 0, because the charged particle needs to be moved slowly. So work done by external agent will be negative, because work done by electric field is positive. So the work done by external agent in APC is negative. Work done by external agent from APC in path APC is negative. Then comes the third path, which is the path AQC. So if you see this path AQC, the path is like this. The path is shown by the red arrow, and the electric field is shown by this green arrow or green line. So you can see that in each and every small part of the path AQC, the small tiny displacement will be in clockwise tangential direction, where the electric field and thus electric force are in anti-clockwise tangential direction. And so the electric field during any small displacement will do negative work, because let us say that the particle has reached this point P and it wants to undergo this small displacement. So the small displacement ds vector is anti-clockwise tangential, whereas the electric field and electric force are in clockwise tangential, which means in this brown arrow which I am going to draw. So this brown arrow is indicating the electric field and thus electric force on this positive charge, and ds displacement, which is in opposite tangential direction, is the displacement. So work done by electric field is negative. So work done by electric field plus work done by external agent is equal to 0. So work done by external agent is negative of work done by electric field, but work done by electric field itself is negative. So work done by external agent is positive. So from AQC, the work done by external agent is positive. So work done in AQC is positive. But as far as magnitudes are considered, the magnitude is same because of the symmetry, isn't it? Same magnitude of electric field like that. Magnitude is same. So if we are talking about magnitude only, then this and this are all same only, and which is greater than AOC. So which is option D if we talk about only the magnitude. Whereas if we talk about the sign also in this work done, then this is the highest. The work done, these all three are work done by external agents, all right. So which is highest in EQC, then in APC, and then in in AOC. So in that case, we will get work done in AQC by external agent is greater than work done by external agent in path AOC is greater than work done by external agent in path APC. So AQC, AOC, there is no option like that. Oh, there is an option like that, and that is C option. So whether we get C option or whether we get D option depends on whether we are talking about only the magnitude of work done or whether we are talking about the work done with the consideration of sign. Normally, if nothing is given, we do consider the work done with sign. So I think the option, the correct answer here should be C. Okay.